This is our video for Tuesday, April 21st for pre-cal, and today we're going to talk about ellipses. You'll need your book open to page 640. Yesterday we talked about circles. Today we're going to talk about ellipses. Tomorrow, hyperbolas. Thursday, writing the equations from graphs or graphs from equations. All the homework is due on Thursday by midnight. And then Friday, we'll have an ACT-style quiz over these topics. And so on page 640, you will find a little definition of the ellipse. And it says an ellipse is the set of all points x and y in a plane that the sum of whose distances from two distinct fixed points foci is constant. So that's a lot of words. But basically you have these two fixed focus points or foci, like cactus and cacti. And if you take the distance from a point on the ellipse, the distance from it to the first focus point and it to the second, and you add them together, you get a certain number. Well, if you move over here and you find another point and you measure this distance and you add them together, it would be the same number. And a point over here, if you take the distance from it to each focus point and add it together, it would be the same. And when you put all those together, you have an ellipse. If we had been in class together, I could demonstrate that for you with a piece of string and two push pins, but we can't do that. But what you need to know is that the ellipse is longer in one direction than the other. With a circle, the radius is the same all the way around, but with an ellipse, you're going to have one direction that is longer than the other. So you're going to have a major axis and a minor axis. So let me see if I can do a little bit of drawing here. So your ellipse can be horizontal or it can be vertical. And the distance from one end to the other, or the line from one end to the other in the longer distance, is called the major axis. And so here, this would be the major axis. And the shorter distance, we have the minor. Of course, the center is where those intersect each other. And A is going to represent the distance from the center to the vertices. So I guess I need to talk about the vertices would be these points where the ellipse touches the axis, vertices, vertex. The distance from the center to the vertices on the major axis will be A. So if this is my major axis here, this distance would be A, and this distance would be A. It's from the center to the edge of the ellipse in the longer direction. B will represent the distance from the center to the vertices on the minor axis. And so in the shorter distance, that's going to represent B. So this is B, A, and A. So A is the distance from the center to the edge on the major or in the longer direction. The minor is this, B is the distance from the center to the edge on the minor. And the major could be vertical or it could be horizontal. So if you look on page 641, you'll see a big blue box, and it gives you two different equations. When you're with a circle, we had one standard form of an equation. With an ellipse, we have two versions. We have the horizontal version, and we have the vertical version. So the horizontal version of the ellipse, we'll call it standard form, or the formula, however you want to say it. The vertical is x minus h in parentheses squared over a squared plus y minus k in parentheses squared over b squared is equal to 1. The vertical is x minus h parentheses squared over b squared plus y minus k in parentheses squared over a squared is equal to 1. And again, a is the distance from the center to the major, or vertices on the major axis. B is the distance from the center to the vertices on the minor axis. And the center will be h and k. So they will give us something like this. X minus 1 in parentheses squared over 25 plus y minus 2 in parentheses squared over 4 is equal to 1. Now, to be able to graph our ellipse, we need the center. And so the center will work just like it did with a circle. And so we're going to have h is with the x and y is with the k. So our center is going to be 1, 2. And our a, now, let me back up here, forgot. If a is the distance from the center to the vertices of the major, and b is the minor, a is larger than b. A is the major, b is the minor, a is going to be larger. So we've got 25 and we have 4. And we've got an a squared and a b squared. Now notice up here, the only difference in the horizontal and the vertical is the a and the b switch. A is the larger. If the larger number is underneath the x, then you're going to go farther in the horizontal direction. If the larger number is underneath the y, then you're going to go farther in the vertical direction. So this one, we have 25 underneath the x and 4 underneath the y. So that tells me this one is a horizontal ellipse. And my a is the square root of 25 is 5. And b is the square root of 4, which is 2. So I've got the information I need. I've got a center. I have a and b, and I know that it's going to be a horizontal ellipse. All right, so I've got my graph paper. I'm going to start my graph. Right. So let's see. We have a center at 1, 2. So I'm going to go to 1, 2. And A is the distance from the center to the vertices on the major axis. It came from the 25, which is underneath the x. So I'm going to, x's go left and right. So I'm going to go from the center, 1, 2, 3, 4, 5. From the center, 1, 2, 3, 4, 5 in the horizontal direction. B is 2. B is the distance from the center to the vertices on the minor. And so I'm going to go in the 2 came from the 4, which was underneath the y. So I'm going to go 2 up and 2 down. And then I'm going to connect my vertices, and they might always kind of end up looking like cat eyes. And so that is how you graph. All right, let's do another one of those real quick. If we had x plus 3 in parentheses squared over 4 plus y minus 2 parentheses squared over 9 is equal to 1. So I suggest that you pause the video and see if you can graph. So our center is going to be negative 3 and 2. So this would be minus h, so this would be a negative 3. K is 2. We need a and b. 9 is larger than 4. The square root of 9 is 3. The square root of 4 is 2. The 9 is underneath the y, so that tells me it's going to be a vertical ellipse. So I'm going to get my graph paper, and I'm going to start my axis. I'm going to graph -3 and 2. Now the 3 came from the 9, which was underneath the y, so I'm going to go 3 up and 3 down because y's go vertically. The 2 came from the 4, which was underneath the x, so I'm going to go 2 to the left and to the right of center. And then I'm going to try and connect these vertices. And again, it kind of looks like a cat eye. So for today, you're going to be doing some graphing of ellipses. And your work is going to be in the book on page 646. I want you to do 7 through 11. And the directions have a whole bunch of, ask you to do a whole bunch of stuff, which isn't necessary for the ACT. And so, again, we're just kind of covering the basics that could help you get an extra question on your ACT, an extra question or two. And so all I want you to do is to graph. Do tell me the center and the A and the B and make a graph. And don't forget Zoom is available every day at 10 o'clock if you have any questions.